Alright, in this lesson we're going to be talking about multiplying and dividing rational expressions. I don't know why, but this is like one of my favorite things to do. Maybe because it has to do with factoring. Woo! Okay, so we're going to start off with some that do not have any addition or subtraction signs. So you're literally just going to simplify them. And we've done these before, okay? But I would look at the number 3 over 2. That doesn't reduce, so this is just 3 over 2, okay? And then I'm going to look at this and say, okay, well, if you're thinking about it, you would just take 7 minus 4. That would give you x to the third. Another way of looking at it is if I have 7 of these x's on top, that would be like saying 3 times x times x times x times x times x times x times x. And then on bottom I would have 2 times x times x times x times x. So I can cancel 1x, I can cancel 2x's, I can cancel 3x's, I can cancel 4x's, and that leaves me with 3x's on the top, okay? Or you could say I can take 4 from both of these, so that leaves me with 3, okay? That's probably the way I prefer, but this is a good way to look at it, okay? And that would be my answer. Now, you have to think about what x cannot be. And when we talk about taking an original expression and simplifying it, then the domains for both of those have to be the same. So if I look at this, I see that in the bottom right here on my original one, I'm going to say original, I see that if I was to set 2x to the fourth equal to 0 and solve for x, I would divide by 2. So I get x to the fourth equals 0, and then I would take the fourth root, which would give me 0. So I know that x cannot be 0. All right? And if I look at my simplified version, which I'll just say that's the SIMP, the simplified version, I don't have an x in the denominator. So there's nothing that x cannot be. But I need for both of the domains to be restricted the same. So since my original one had to be not equal to 0, then I have to add that stipulation here that x cannot be 0, even though there's no x in the denominator of the simplified version. All right, so if you look at this one, 16 divided by 8, well, that's 2. And then I've got 2 x's on bottom and 11 on top, so I can take 2 away from both of those. That leaves me with 9 of them on the top. And that would be my answer, but I have to think about the domain. So remember, we don't want a 0 in the denominator. So if I were to take 8x squared and set that equals to 0 for my original equation or expression here, that would show me that x cannot be 0, because if I plug a 0 in here, 0 squared is 0, times 8 is 0, I would get a 0 in the denominator. But I don't have a denominator here, so I'm going to have to go ahead and restrict the domain for my simplified version because there's literally nothing. So I'm just going to put none. And we're going to do this on every single problem, so you should get really good at this. Okay? Now, let's look at something that is a little bit different. So I see that I have a trinomial on top. Well, if I want to be able to cancel factors, okay, it's kind of like if I have a 6 divided by 3. We all know that that's 2. But why is it 2? It's 2 because 6 is the same thing as 2 times 3. And when I'm multiplying factors, I can cancel a whole factor out. That leaves me with just 2. So we're essentially going to do the same thing with these polynomials. So I have a trinomial on top, and I know that I can factor that trinomial. Since there's a minus in the back, I'll have 1 plus and 1 minus. To get the x squared, I have x times x. And what multiplies to make 3 and subtracts to make 2, that would be 3 and 1. And since there's a minus in the front, the bigger of those two numbers goes with the minus. So 3 goes with the minus, and 1 goes here. Then I see the bottom is also a trinomial that I can factor. So I'm going to go ahead and factor this. I've got a plus in the back, so that's 2 of what's in the front. And then I have x and x. And what multiplies to make 4 and adds to make 5, that would be 4 and 1. So I look at this and I go, okay, well, I see that in my denominator, I have an x plus 4 and an x plus 1. So if I were to set x plus 4 equal to 0, I'll just kind of do this out to the side, then that means that x cannot be negative 4, because if I plug negative 4 in here, negative 4 plus 4 is 0. 0 times all of this would just be 0, and I'd have a 0 down here. So x cannot be negative 4. Well, if I do the same thing with the x plus 1, I would just subtract 1. So x cannot be negative 1. And I'm not going to actually write that out every single time. Okay. So remember, I only care about the ones in the denominator. All right. Then I want to simplify. Well, if I have a factor of x plus 1 on top and a factor of x plus 1 on the bottom, those are going to cancel, and that leaves me with x minus 3 over x plus 4. I don't need the parentheses anymore because that was showing me that I was multiplying times this, but now it's gone, so I don't need it. So if you look at the bottom on this one, there's only one factor that has an x. It's x plus 4. So if I set that equal to 0, then it shows that x cannot be negative 4, because negative 4 plus 4 would be 0, and I would have a 0 in the denominator. All right, so if I look at this, in my original expression, x couldn't be negative 4 or negative 1. When I simplified it, then I showed that x couldn't be negative 4. Well, since these two are in both of them, I don't need to state that down here. I just need to go ahead and restrict my simplified version to show that x cannot be negative 1. So essentially what you're doing is, if you have one listed, an x value that cannot be included in your domain in the original, it's also listed as something that x cannot be for your simplified version. You're just going to come say, okay, well, it was in both of them, so I don't need to make any other stipulations. So this is the only one that I need to state down here at the bottom. So if it matches, you don't need to write it. Okay, that's kind of how I'm looking at it. So if I look at this top part, 3x plus 4, there are no common factors between those two, so I'm going to leave them be. On the bottom, I've got 3x squared plus x minus 4. Well, I can't do the tricks to factoring if I have this 3 out front. So I'm going to take the 3 times the number at the back, and that would give me x squared plus x minus 12. And then I'm going to factor that like normal. So our numerator is just going to kind of chill for a while. A minus in the back means 1 plus, 1 minus. I've got my x and my x. And what multiplies to make 12 and subtracts to make 1, that would be 4 and 3. And since there's a plus sign in the front, the bigger of those two goes with the plus. So 4 goes here and 3 goes here. Then I have to remember that once I get that factored, I have to undo the multiplying by 3. So I take both of these and divide by 3. If I can reduce, remember you should reduce. I cannot reduce 4 over 3. So I'm going to take that 3 and move it in front. So I would get 3x plus 4. Remember the 4 stays at the back. And then back here, 3 divided by 3 is 1, so this will be x minus 1. So now I have factored my original. So for my original, if I were to set 3x plus 4 equal to 0, I would subtract 4 and divide by 3. So x cannot be negative 4/3. And then if I set x minus 1 equal to 0, x cannot be 1. All right, then I simplify. So I see that I have 3x plus 4. That matches with my factor of 3x plus 4 on bottom. Now, this leaves with a 1 because anything divided by itself is 1. So this will reduce to 1 over x minus 1. Again, parentheses are not needed because I'm not multiplying by anything down here anymore. So the only thing in my simplified version that x cannot be, I would set the x minus 1 equal to 0. So x cannot be 1. So I see that that was already a restriction for my original. So I don't have to write that one down, but I do have to write the x cannot be negative 4/3. That way I've restricted the same thing for both my original and my simplified version. Okay, something I do want to show you that's kind of cool is this right here. So if you look, when I take this and I simplify it, it's still the same thing. So in other words, if I take 6 divided by 3, that still has the same value as 2, okay? So actually, if I were to graph this, and I've already put them in, so this was my original, and this is my simplified version. If you graph them, so the first one graphs in blue, and since they're the same thing, they should be the same graph. So if you're watching it, okay, this one is in blue, and then my second one in red covers up over that. Now, that doesn't go to say that if they cover, then you've done it correctly. I mean, you could have not reduced all the way or something like that. There are many forms of something. But it is a good way to show you. I mean, you could see if you're completely off. The other thing I want to show you is on the table. Okay? So if you'll remember from this, the first one was undefined when x is -4 and x is -1. So if we look at this, if I go to -4, see how we're undefined on the first equation, but we're not on the second one? And then if you look at -4, we're undefined for both. Okay? So I feel like that's like really interesting. Okay? So that's a good way to check to make sure that you have the proper restrictions on your domain. So the one that matches is not the one that you're going to have written down because it is already a restriction for both. It would be the one where you have an error for one and not on the other, okay, which is where we restricted ours right there at -1. So I thought that was kind of a cool thing that might help you. All right, so I see that on number 5 here I have a number in front, so I'm going to have to take that times the back, which will give me 12. And then on the bottom, I'm also going to have to take that 6 times the 6 back here, so that would give me x squared minus 5x minus 36. And then I'll do my factoring. So on top, I've got a plus at the back, which means 2 of what's in front, which is a plus sign. Then I have x, and what multiplies to make 12 and adds to make 7 would be 4 and 3. And since both my signs are the same, I don't have to worry about changing that. But I can't forget that I have to divide by that 6 that I multiplied by. So I'm going to divide by 6. Then I'm going to do the same thing on the bottom. Only this time I have a minus in the back, so that's automatically a plus and a minus. And I have x and x. And what multiplies to make 36 and subtracts to make 5, that would be 4 and 9. And since there is a minus in the front, I'm going to put the 9 with the minus and then the 4 with the plus. Then I'm going to have to make sure I divide by 6 because that's what I multiplied by to begin with. And if you don't feel comfortable doing these at the same time when you're doing your homework, you can always do one and then go do the other. So 4 over 6, that reduces to 2 over 3. And 3 over 6 reduces to 1/2. So if I were to pull the bottom forward, that would be 3x plus 2. And back here, I'd pull the 2 forward. That would be 2x plus 1. Always reduce. Okay. 4 over 6, that reduces to 2 over 3. And 9 over 6 reduces to 3 over 2. So I'll pull the 3 forward. Plus 2. And then I'll pull the 2 forward. So for my original, I'm going to look at those bottom factors. If I were to set 3x plus 2 equal to 0, I would subtract 2 and divide by 3. So x cannot be -2/3. And then if I were to set this 2x minus 9 equal to 0, I would add 9 and divide by 2. So x cannot be 9/2. Then I'm going to simplify this. So I see that I can cancel out the 3x plus 2. And that leaves me with 2x plus 1 over 2x minus 9. So the only factor I have left in the denominator is 2x minus 9. So if I set 2x minus 9 equal to 0, I would add the 9 and divide by 2. So x cannot be 9/2. Since that's already a stipulation for the original, the only one that I need to restrict would be the -2/3. So x cannot be -2/3. All right, so if I look at number 6, this is just straight up factoring. I have a minus at the back, so that's a plus and a minus. I've got x and x, and what multiplies to make 2 and subtracts to make 1 is 2 and 1. Since there's a plus in the front, I'm going to put my 2 with the plus and my 1 back here. Bigger always goes with what that sign is. And then I'm going to factor the bottom. So I have a minus in the back, that's a plus and a minus, x and x. And what multiplies to make 3 and subtracts to make 2 would be 3 and 1. Since there's a plus in the front, I'm going to put the 3 with the plus and the 1 with the minus. So now that I've factored that for my original, to restrict that domain, I would set x plus 3 equal to 0. So x cannot be negative 3. And when I set x minus 1 equal to 0, x cannot be positive 1. Then I'm going to simplify. So I see that I have a matching factor top and bottom, the x minus 1. So I'm going to cancel that. That leaves me with x plus 2 over x plus 3. And so the only thing left in the bottom is the x plus 3. If I were to set that equal to 0, x could not be negative 3. Since that's already a restriction in my original, the only thing I need to restrict would be the 1. So x cannot be 1. All right, 7 is a little bit wonky. Okay, I don't like that this x squared is at the back. So what I'm going to do is first I'm going to move the negative x squared to the front, just because that's my preference. And I do notice that I may have just 2 terms, but I do have a common factor. I also know that I don't like this negative in front of this x squared. So I can remove an x from the first and the second term, and I'm going to take a negative out as well. So if I take out a negative x squared divided by negative x is a positive x, and 2x divided by negative x is negative 2. All right, when I factor on the bottom, I have a plus and a minus, x and x. And what multiplies to make 2 and subtracts to make 1 would be 2 and 1. And since there's a minus in the front, the bigger of those goes with the minus. So if you forget to take out the negative, you end up with this. And then you should see that it's really similar to this, except the signs are different. And that should lead you to take out the negative. All right, should. All right. But I just don't like for that front number to be negative anyways. So I look at this. So for my original domain restrictions, I would set both of these factors equal to 0. So x cannot be negative 1, and x cannot be positive 2. Then I'm going to go ahead and simplify. So I have x minus 2 on top, x minus 2 on bottom. That leaves me with negative x over x plus 1. So the only factor left in the bottom is x plus 1. So if I set that equal to 0, x cannot be negative 1. Since that's already a restriction for my original, the only thing I need to restrict is the x cannot be 2. All right, number 8. So again, I don't like this because the x is at the back, so I'm going to move the negative 2x to the front, and I'm going to put the positive 10 at the back. So I see that I have 2 terms, and I have a common factor of 2, but like I said, I don't like for this term in front to be negative, so I'm going to take out negative 2. Negative 2x divided by negative 2 is positive x, and 10 divided by negative 2 is negative 5. On the bottom, as you can see, you already have a factor of x minus 5, so we're going to leave that alone. We can't factor it anyways. So the only thing from my original expression on bottom is x minus 5, so that means x cannot be 5, right? 5 minus 5 gives me a 0 down here. So if I go ahead and simplify, I can cancel the x minus 5 on top and bottom. All I have left is negative 2. But I see that I don't have a denominator, so there's nothing to be restricted for my simplified version. So since I don't have a matching factor here, right, I'm going to have to restrict this to x cannot be 5, which kind of seems odd since there's no x left, but you still have to state that. All right, so on number 9, I see here that I have 2 terms on top, and I have a common factor of x, but I don't like that this first term is negative, so I'm going to go ahead and take out a negative x. Negative x squared divided by negative x is positive x, and 3x divided by negative x is negative 3. Then on the bottom, I'm going to have to do the illegal move because I have a number in front, so 2 times 3 would give me 6. I'm going to kind of do it out to the side, that way I don't have to write this so many times. All right, and if I were to factor this, I would have two minus signs, x and x, and what multiplies to make 6 and adds to make 7 would be 6 and 1. And then I have to remember to divide by 2. So 6 over 2, that reduces to 3. And then 1 over 2 doesn't reduce, so I'm going to pull the 2 to the front. So 2x minus 1. So for my original expression, I would set both of these equal to 0. So x cannot be positive 3 because 3 minus 3 is 0. And x cannot be a positive 1/2 because I would add the 1, divide by 2. So I'm going to simplify that. And I can cancel out the x minus 3. So that leaves me with negative x over 2x minus 1. So the only factor left in the bottom is 2x minus 1, so x cannot be 1/2. Since that's already a restriction in your original, then you only need to restrict the 3. All right, so let's talk about multiplying. So we have already done some like this, but we'll do them again. All right, there's multiple ways to do these, okay? I'm going to multiply across and then reduce. I feel like that would be easier. You could start canceling everywhere. I think that gets a little hairy sometimes. So notice there's no plus or minus signs in these first two problems. So I can just multiply straight across. So 2 times 15 is 30. X squared times x squared, I just add those exponents, so that'd be x to the 4th. And then I have y to the 5th and no other y to the 5th, or no other y's. So I just get y to the 5th. On the bottom, 3 times 8 is 24. I have x squared times x to the 3rd is x to the 5th. And then the only y I have is this y squared down here on the bottom. All right, so then I'm just going to reduce each little part. So in other words, you're going to kind of view this 30 over 24. Now, if you don't want to reduce that by hand, you can just plug it into your calculator. So if I put in 30 over 24, it reduces that for me to 5/4. So I'm going to have a 5 on top and a 4 on the bottom. All right. I have 4 x's on top and 5 on the bottom, so I can take 4 from each of those, so that leaves me with 1 x on the bottom. And then I have 2 y's on bottom, 5 y's on top, so I can take 2 away from that, which leaves me with 3 y's on the top. So let's look at our denominator that we put together. Okay, I'm multiplying all this together. So for my original, x cannot be 0 and y cannot be 0 because I'm just multiplying all of these together. All right, for my simplified version, the only thing I have in the denominator is 4x. If I set that equal to 0, x cannot be 0. Since that's already restricted for my original, I just need to restrict the y does not equal 0. I don't have to state the other one because it's the same for both. All right, so if I multiply across here, I may have 3 things, but it's still the same thing. It's like 1 times 20 is 20. And then you have x to the 1st and x to the 7th. That's x to the 8th. 15 times 2 times 1 is 30. X to the 1st times x to the 4th is x to the 5th. And then you just have to reduce from there. So 20 divided by 30 is 2 over 3. I have 5 x's on bottom and 8 on top, so I can take 5 from both. So that would be x to the 3rd. So if you look at your denominator for your original one before we started canceling, the only thing down there was 30x to the 5th. So if I set that equal to 0, x cannot be 0. For my simplified version, I only have a 3 down here, and I'm not going to set 3 equal to 0 because that doesn't make a true statement. So I have no x's down here to worry about, so there's nothing. But I need to restrict this the same that this original was restricted, so I will state that x cannot be 0. Remember, if you don't have a matching set, then you're going to have to state that. All right, when we throw in some plus and minus signs, then that means that we're going to have to actually factor every single numerator and denominator. So I'm going to have to take this and factor it if I can, this and factor it if I can, this, and so on and so forth. So x plus 2, there's no common factors there. It's only two terms. They're not perfect squares, so I can't do anything with x plus 2. But if I look on the bottom of that, I've got 3x plus 12, so I have a common factor of 3. So I'm going to take out a 3. 3x divided by 3 is x, and 12 divided by 3 is 4. All right, then I do the same thing over here. X plus 4, no common factors. I can't do anything with that. But I do realize that x squared minus 4 is the difference of two squares. So I will factor that one. Remember, that always gives you a positive and a negative. Square root the front, that's x. Square root the back, 4, which would be 2. So if you look at all the factors that have an x down here, you have x plus 4. So for my original, x cannot be negative 4. Look at this denominator. X cannot be 2, and x cannot be negative 2. So I have 1, 2, 3 factors that have an x in the denominator that are causing problems. Now, since I am multiplying, I can cancel factors from top to bottom. So x plus 2 divided by x plus 2 is 1. X plus 4 divided by x plus 4 is 1. So on top, 1 times 1 is 1. And then down here I have this 3 left and the x minus 2. So the only factor I have left is the x minus 2. So if I set that equal to 0, for my simplified version, x cannot be positive 2. So the only thing that's already the same as far as the restriction for my original is the x cannot be 2. So I have to state that x cannot be negative 4 and x cannot be negative 2. So if I look up here, I can factor out a 10. So I have 10x divided by 10 is x, and negative 40 divided by 10 is negative 4. All right, on the bottom I have a trinomial, so I can factor that. I have a plus in the back, which gives me 2 of what's up in the front, and then I have x and x. And what multiplies to make 8 and adds to make 6 would be 4 and 2. I can't do anything with just an x plus 3. But on the bottom, I see that 5x and 15 both have 5 in common, so I'll factor out a 5, which leaves me with x plus 3. So if you look at all the factors in the denominator that have an x, I have x minus 4, so x cannot be positive 4. I have an x minus 2, so x cannot be positive 2. And I have x plus 3, so x cannot be negative 3. Then I'm going to simplify this. So I see that I have x plus 3 divided by x plus 3, that's 1. And then x minus 4 divided by x minus 4, and that's got a 10 left, so 10 times 1 is 10. And I also see that I have 10 and 5 right here, so I can reduce that as well. Now let's say that you don't do that. You have 10 times 1 is 10, and then you have 5 times x minus 2. At this point, you should realize that you can cancel those out. Or you could just do it from here. 5 goes into 10 2 times. So if you do that here, 5 goes into 10 2 times, and you get 2 over x minus 2. So make sure you fully simplify that. Okay? So on the bottom, I have x minus 2, so x cannot be positive 2. So that's only one restriction that matches, so I'm also going to have to restrict where x cannot be 4 and x cannot be negative 3. All right. Oh, I think I skipped one. All right, so on the bottom, I cannot factor x minus 3, or on the top. On the bottom in my denominator, we have a 4 in common, so if we take out a 4, that would be x plus 5. I can't do anything with x plus 5, but I do have the difference of two squares in the denominator. So I'll have a plus and a minus, x and x, and the square root of 9 is 3. All right, so if I look, I have 3 factors with an x. So for my original, I have to restrict my domain. So x cannot be negative 5, negative 3, positive 3. Then I'm going to go ahead and simplify, so I can cancel out the x minus 3, the x plus 5. So all I have left in top is 1 over 4 times x plus 3. So the only factor in the bottom I have is the x plus 3. So for my simplified version, the domain would be x cannot be negative 3, which matches this in the top. So I still need to restrict for negative 5 and positive 3. I honestly probably prefer that you would actually put this back together, but if you're doing homework online, then it's not going to, I think it wants it separated. I'm not really sure yet how picky it will be. All right, so dividing is kind of the same, so we're going to kind of throw back to middle school to the keep, change, flip, also known as multiplying by the reciprocal. So if I am taking two fractions and dividing them, I will keep the first fraction or the one on top, because you could also write this as x squared over 4, and then on the bottom, x to the 4th y over 12y squared. So I would keep the top fraction, in this case the front fraction, change division to multiplication, and then I would flip the one that's on the bottom, or this second one. Okay? So you kind of have to think just a little bit differently about what x and y cannot be. Okay, you have to pay attention to this denominator, this numerator, and this denominator. All three of them matter, and that's because right now this is in the denominator. But then if I flip this, then this is in the denominator. Okay, and also this whole fraction is in the denominator. So you kind of have to pay attention to all three. So I don't have an x here, but I do have x to the 4th times y. If I set each one of those equal to 0, x cannot be 0, and y cannot be 0. Same thing in the bottom, y can't be 0. So for my original, neither x or y can be 0. Now, the only difference in the dividing ones is that you keep this first fraction, you change division to multiplication, and you flip this one. So now the 12y squared is on top, and the x to the 4th y is on bottom. Now it's exactly what we've been doing. It's just a multiplication problem. All right? So I'm going to multiply across. 1 times 12 is 12. I have an x squared and a y squared. And then on the bottom, 4 times 1 is 4, and then x to the 4th and a y. All right, so I've got 12 over 4 is 3. I have 2 x's on top and 4 on bottom, so I can take 2 away from both. So that just leaves me with x squared on the bottom. And then I have 2 y's on top, 1 y on bottom, so I can take 1 from both, so I have a y on the top. So if I look at this, for my simplified version, the only thing I have in the denominator is x squared. So if I set x squared equal to 0, I get that x cannot be 0, which is already a restriction for my original. So I'm just going to add the restriction that y cannot be 0. All right, now we've got some plus or minus signs. So I'm going to look at all three of these, okay? I have to look at this one, I have to look at this top, and I have to look at this bottom right here. So the first thing I'm going to do is I'm going to factor all of them. All right, so I have 7x, I can't do anything with that. 2x minus 10, I can factor out a 2, so that leaves me with x minus 5. Still keeping the division for now. I see that I have two terms up here, but they have a common factor of x, so I'm going to take out an x, which will leave me with x minus 6. And then I'm going to go ahead and do this bottom. Okay, so I have a plus in the back. That's a plus minus minus, because I have a minus in the front. X and x. And what multiplies to make 30 and adds to make 11 would be 6 and 5. So now that I'm all factored, I'm going to pay attention to this denominator, this numerator, and this. So when I do multiplication alone, I just pay attention to both bottoms. When I do division, I have to pay attention to all three spots. So if I look at this, I have x minus 5. So if I set that equal to 0, x cannot be 5. I have two factors up here, okay, of this lonely x. So x cannot be 0, so because if I set x to 0, that's just 0. I also see that x cannot be positive 6, because 6 minus 6 gives me 0. And then I already took care of both of these, a 6 and a 5. All right, so I have 3 things. Now I'm going to simplify. So if I'm dividing, I'm going to keep the first fraction, and then I'm going to flip the second one. So what's on the bottom will be on top, and what's on top will be on the bottom. All right, so I see I have x minus 6, x minus 5, and then I also have x and x. Now let's say right here you don't realize that those x's, you've got 7x times 1, that's just 7x. And now I just have 2 times x on bottom, that's 2x. And then right here you should say, oh, I can cancel the x's, so I just get 7 over 2. I don't have any x's in the denominator, so there's nothing that needs to be restricted when it's simplified. But remember, my restrictions have to match the original, so I'll have to list all of them. So x cannot be 5, x cannot be 6, and x cannot be 0. All right, so remember, you're paying attention to the bottom here, the top here, and then this is sitting on top of a 1, so there's no x's down here. So I'm going to go ahead and factor all of this. So I'm going to have to do the illegal move, so I'm going to do it out here to the side, so I don't have to write it a bazillion times. So I'm going to take the 2 times the 5 at the back, which gives me 10. And I have a plus and a minus, x and x. And what multiplies to make 10 and subtracts to make 3, that would be 5 and 2. Since there's a plus in front, the bigger goes with the plus, so 5 goes with the plus. And then I have to remember to divide by 2, because that's what I multiplied to begin with. All right, so I'm going to pull the 2 to the front. So I get 2x plus 5. 2 over 2 reduces to 1, so I just have x minus 1. I can't factor 6x. But I do have a common factor of x up here, so I'm going to take out the x, and that leaves me with 2x plus 5 all over 1. So for my original, the restrictions would be I'd set 6x equal to 0, so that would just divide by 6, so x cannot be 0, because 6 times 0 is 0. That takes care of this one, because if I set x equal to 0, same thing. And then 2x plus 5, I set that equal to 0, I would have to subtract 5 and divide by 2, so x cannot be negative 5 over 2. Then I'm going to simplify. So I keep the front fraction. Change division to multiplication. Flip. So I have 2x plus 5. And then that's it. So x minus 1 times 1, that would just be x minus 1. And 6x times x would be 6x squared. So if I set that denominator equal to 0, x cannot be 0, which is already a restriction for the original. So I will just also restrict the negative 5 halves.